Well, my friends, in the previous videos, we've covered essential steps in pre-processing our EEG data, including filtering and utilizing independent component analysis to eliminate various artifact patterns. However, despite our efforts, there might be still lingering artifacts that could impact the quality of data. In this video, I will teach you the process of manually removing any remaining artifacts through visual inspection. Yes, my friends, visual inspection is important. As sophisticated as algorithms and tools may be, the human eye remains a powerful instrument for identifying patterns and anomalies. First, we begin by reviewing the pre-processed data. This involves examining the entire dataset, paying close attention to areas where artifacts may still persist. Alright, let's open the EEG file again using the plot function. If you want to generate the output, that says using matplotlib as backend and the output image, as I mentioned in the section on plotting graphs, you can use plt.show to remove this output that you see here in your workspace. However, to do this, we need to start by adding the matplotlib library at the beginning. So I will here import matplotlib.pyplot as plt, and then at the end I will place this code plt.show to remove the output that we see in our workspace, so we only see the signal in a new window. Let's check our signal. You can also remove bad channels, my friends. For example, let's say we don't want, for example, FP2 in the final analysis due to its high noise. Simply go to the interactive window, actually the window that we are in right now. Click on the name of the signal, click on the signal that you see. So if you click on the signal, you can remove any channel that you want. As you can see, the channels become fainter. It is easy to select any of these channels. Go over the signal's name and click. Once we close the window, the report will actually inform us that the channel has been removed. On the other hand, you might also want to place a guide marker, and this feature is available here. In general, in this window, if you press the left and right keys, you can also navigate to the left and right in the EEG recording. You can also use page up and page down. And as you can see, when you press page up and down, you can increase or decrease the visible number of channels. When the number of channels decreases, you can scroll up or down to see the other channels. Now, let's consider that we are going to remove FP1 and FP2, so we select them here. On the other hand, if you press the A key here, while we are in this window, a mode called annotation opens. And in this mode, we can assign specific labels to the noise we manually remove. For example, here it says new label, and I want to label it as, for example, bad muscle. So I type this phrase here and then click on add new label. A new label is added to the annotation window with the title I assigned to it. Next, while still in the annotation mode, I can manually select a proportion of the signal that I want to exclude by dragging. So for example, here you can see that around 48 to 52 seconds, I have a muscle noise. So I will drag this part, and as you can see, this segment is highlighted. I can proceed by using the left and right keys, navigate to any part of the signal where there was any noticeable muscle activity, and drag to select it again. For example, here around 130, we don't see any noticeable noise. When we go further, we can observe several noises, such as muscle activity, like what we see here. So for example, here I can see another muscle activity, so I will select this part as bad muscle. And also, if you review the data, you can see that there are several other artifacts. For example, around 130, you can observe something which is a bad sensor artifact. Let me show you, for example, around here. As you can see, this part of the P4 electrode is actually something like a bad sensor. If I need to create a new label, so I can again open the annotation window and then create another label, this time bad sensor, and then again add new label. So here we have to choose bad sensor from the existing labels and drag this part. And here you can see that this is considered as a bad sensor. And as we progress through the recording, if we identify any other muscle artifact, for example, I can again go back to the annotation mode and choose bad muscle and drag the part of the signal. So for example, here again, suppose it is a bad muscle. So again, I select and highlight the part of the signal and proceed in this way until the end of the signal. Finally, from this point forward, any operation performed on the variable that we are plotting excludes the segment with the keyword bad underline. The manually marked segments in the signal are reflected when closing this window. So when I close this window, I will see that we have channels as marked as bad channels, FP1 and FP2. It first shows the channels that are marked as bad, indicating that these two channels have been excluded. Additionally, any further analysis performed will not include the segments marked with bad underline. In this way, the clean file is ready for subsequent analysis on the data, and at the end, I can save this file for further analysis. Now, we've successfully navigated through filtering, ICA, and artifact removal to enhance the quality of EEG data. Exciting, right? Well, our data, refined and ready, sets the stage for the grand spectacle of analysis that awaits us. But wait, there is more. In the upcoming section, we will do a series of frequency analysis, first in Python itself, and then we will use M&E. Trust me, it's where the real magic happens. So stay with me because things are about to get even more fascinating. Thank you and see you in the next video.